This is a movie-based question. So I'm going to start by hiding the menu. Now, it says press run to see how the robot moves. So we can pause this execution and we have a slider that allows us to go through time, which goes from 0 all the way to 100, and examine at each of these individual time intervals what exactly is happening. Again, it's very useful to read through the information so that we know exactly how to approach this problem. The colors shown are faded version of the true colors. The pentagon is purple, so this is middle right in the color picker, and we'll have a look at what that means. The line that forms the leg is black, and that's bottom right in the color picker. The line thickness and the number of sides are both 5. All other variable values are multiples of 10. This is what I was referring to earlier about them indicating in the information what values we should use. So we have a new tab here, which is the movie tab. And this includes the time block. Now we're going to get to this in a second, but before that, let's have a look at the shapes. So let's try running this shape over here. This has created a red circle in this position. So if we have a look here, we have the number of sides, and the way it works for this shape is if we put 10 sides, it creates a circle. Well, they told us here that the number of sides we need for the pentagon are 5. The color we need for the pentagon is purple. So we click through here, and they've even indicated where this lies in the color picker. It's middle right, so it's this one over here. So let's try that. Now we have the correct shape, the purple pentagon, but we need to make sure that this is placed in the correct position. So we're going to do what we did in the previous question, and we're going to look at the center of the pentagon. So the x-coordinate of the center, if we look up at these indicators, is 20. So it's actually in the correct x position. The y position is 40. So we're going to need to adjust that so that it becomes 40. Now if we run, the pentagon is in the correct starting position. But what happens if we keep going through the time using our slider is at time equals 40, you see that the pentagon starts moving to the right. And this keeps happening until time equals 80, and then it stays in place. So we'll worry about the leg of the robot later. Let's just think about the pentagon itself now. It starts in this position. It moves as time goes along, and then it stops. So this is where we could use this time block. This takes value exactly equal to the time indicated here. So for example, if I put that the x position is equal to time, this means at time 0, the x-coordinate will be 0. And as time increases, this x position will increase. So when time is 40, it's going to be 40. When time is 50, x is going to be 50. And it moves according to this time. But what we want to do is actually have it stationary, have it stopped in its position up until time is 40, and then it starts moving, and then have it stop again at 80. So we're going to have a think about that. But before we do that, let's also think about our line. Let's just disable this block for now so we can clearly see the line. So we have the Shape tab to create shapes like pentagons, circles, squares. Then we have the Line tab. Now here it looks similar to the shape in that you can create a certain name for it. So we can call this the pentagon, and we can call this the line. It's similar in that it has a color picker as well. They said the line that forms the leg is black, and that's bottom right. So it's this one over here. The line thickness, just like the number of sides, is 5. So we're going to change the thickness to 5. And let's just have a look at where this line is right now. So it's starting at 0, 0, so over here in the corner, and it's going all the way to 20, 20, this point over here. So for a line, we choose its thickness, where it starts, and where it ends. Well, let's try setting it to this position. It starts at 20, and the Y position at the start is 50. And where does the line end? Well, it goes all the way over here. So the X position is 0, and the Y position of the end is 90. So we run that, and in fact, it is in the correct place now. But the line moves immediately from the start, and it actually changes position quite a few times. Now, what we notice is from time 0 until time 40, it's just the end position of the line that changes. It's still starting from the same place, but the end position is changing from 0, 90 to 40, 90. Then between time 40 and 80, it's the start position of the line that changes. And then after time 80, we have the end position of the line changing again. All right, so how do we deal with these changes in position using the time? Well, the easiest way to do this, since we have two shapes that are changing positions at different points of the program, is we could go into the Logic tab and we could start an if statement. What this does is it checks some condition. If something happens, then do a certain thing. So we're going to start by saying if, well, what did we say? The first changes are going to happen between time 0 and time 40. So we're going to use this logic block, which allows us to do equality as well as inequalities. And in here, we can say less than or equal to, and we can use the time block that we talked about, right? So we could do if the time is less than or equal to, well, the first block, as we said, is going to be all the way up until 40. So if the time is less than or equal to, we need to put a 40 here. All numbers and mathematical operations can be found in the Maths tab. We're going to grab this block, put it over here, and we can change the number to 40. So we're saying if the time is less than or equal to 40, so from 0 to 40, do the following things that we're going to put in here. Well, we're going to add a pentagon that is in this position, and it's not going to change position in these first 40 seconds. Then we add the line, which does change position in these 40 seconds, or 40 time intervals. So, as we spoke about before, the start position of the line does not change. It's the end position that changes. Well, the y position of the endpoint does not change. It starts at 90 and it finishes at 90. So we're going to keep this as it is. And of course, as we said, the start position will remain unchanged. But it's this value that we need to change. At time 0, the x-coordinate of the endpoint is 0. And it changes exactly with time. So when time is 10, the x-coordinate of the endpoint is 10. When time is 20, the x-coordinate of the endpoint is also 20. And this keeps happening until it gets to 40. So here also we have when time is equal to 40, the x-coordinate of the endpoint is 40. So actually, the x-coordinate of the endpoint is equal to the time value. So we're going to use this time block again and set it as the x-coordinate of the end position. And now you can see that the leg moves correctly as time goes along. And this is all the way up until the time is 40. Then, the next block we have to worry about is this time interval between 40 and 80. Because after 80, it's a different movement. So we're going to leave that as a separate block. We're just going to do 40 until 80. Now, we can see on this if block something that we haven't seen in a block before, and it's this blue icon with a cogwheel on it. This allows us to change certain things about the block. This currently says, if this condition is true, do the following. So if time is less than or equal to 40, add the pentagon in this position over here, and add the line with this starting position and an ending position where the x-coordinate follows the time exactly? Well, we can add two different things. The first thing we're going to add is an else-if statement. This means check the condition at the if first. So if time is less than or equal to 40. So when this condition is true, it's going to run these blocks. When this condition is false, so time is not less than or equal to 40, it's going to go and check another condition. And in here, we're going to do something similar. Remember, we can right-click and duplicate, and that saves us some time when we're completing the challenge. And what I'm going to do is say time is less than or equal to 80. Now, it's important to understand why we can do this without worrying about whether what we put here will be executed even between time 0 and 40. Because technically, 0 to 40 is less than or equal to 80. But it always checks this condition first. And the only way it gets to this point to check this condition is if this one is false. So if time is greater than 40. So this is saying if time is greater than 40 and it's less than or equal to 80, do the following. And this is quite useful for us because this is exactly what we need here. We want something to apply between time 40 and 80. And what we're going to do is, in this time frame, we also want to add the same shapes. We have the pentagon and we have the line, but we're going to need to change around their positions. So I'm going to duplicate each one. Let's do the pentagon first. Now, the pentagon, we've put it at this position, so at its starting position, but we actually want it to change its position as time goes along between 40 and 80. So let's think about what's changing in its position. Once again, the y-coordinate, so where it lies vertically in the canvas, is unchanged. It's not moving up or down, it's moving to the right. So the x-coordinate is changing. The x-coordinate is changing from 20 at time 40 to 60 at time 80. And here we're going to have to use some maths to think about how this x position corresponds to the time. Let's think about it again. When time equals 40, the x-coordinate is 20. So if we think about it, the difference between the x-coordinate and the time is 40 minus 20, which is 20. So this is 20 less than the time. Let's check what happens at time 60. When time equals 60, the x-coordinate is 40. So once again, the x-coordinate is 20 less than the time, right? There's a difference of 20 between the x-coordinate and the time. And it keeps going all the way up until time becomes 80 and the x-coordinate is 60. Once again, we see that there is this difference of 20 between the x-coordinate and the time. So we're going to keep the y-coordinate unchanged, but the x-coordinate is always 20 less than the time. So we're going to need to use a maths block. And in here, we're going to do a minus. We're going to say it's time, take away 20 to get the x-coordinate. So let's check that this does the correct thing. It stays fixed for the first 40 seconds. Then it starts moving as the time goes on, all the way up until it's 80. And notice that after 80, we still haven't said what's going to happen. So the shape disappears. So before we get to that final phase of the question, we still need to think about the line. I'm going to disable this again, just so we can clearly see the line. Because between time 40 and time 80, it's the starting position of the line that's changing. Whereas before, it was the end point of the line that was changing. So in the first 40 values of time, the endpoint was changing. Then that stays in place where the x-coordinate is 40, the y-coordinate is 90. The endpoint stays in place, and it's the starting point that starts moving. Well, we're going to duplicate this again because we need the same line, as in the same color, the same thickness, but we need to rethink the start and end position. Let's start with the one that stays fixed, the end point. We said this is x-coordinate 40 and y-coordinate 90. So the endpoint does not move. We just need to change the start point of the line. Well, once again, we see as the line is moving, the start point doesn't move up or down. So actually the y-coordinate is unchanged. It's just moving to the right. So it's the x-coordinate that is changing. And it goes from 20 all the way to 60. Let's check that again. At time equals 40, the start point has x-coordinate 20. Do you see the pattern? Again, the x-coordinate is 20 less than the time. And you can see actually it moves at exactly the same speed as the pentagon. So it's moving just like the pentagon. And at the end, we have an x-coordinate which is 60, also 20 less than the time. So we can use exactly this same formula, which is time minus 20 to determine the start position or the x-coordinate of the start position of the line. And let's just enable this to make sure we've got the right thing so far. So from time equals 0 to time equals 40, we have the end point of the line changing. Then the end point gets fixed, so it's not changing. And now it's the pentagon, or rather the x-coordinate of the pentagon and the x-coordinate of the starting position of the line that are changing. They're shifting to the right, and they're always 20 less than the time. And then we get to the final phase, which is what happens after time equals 80. And once again, we're going to have to revisit this blue cog and say, now we're going to add an else statement. This is slightly different to the else if. So else means get here if the previous condition was false, and if checks a condition. So this kind of does both. It's saying if this is false and this is true, do the following. So if time is greater than 40 and less than or equal to 80, do the following. Else has no condition. Else just means if all the conditions that we have checked are false, do what's inside here. So if time is not less than or equal to 40, and it's not less than or equal to 80, which means if time is greater than 80, which is this segment that we want. Well, once again, just like the first segment, here, the pentagon is not moving. The start position of the line is not moving. So let's start with those because those are easier to program. We're going to duplicate this pentagon, and we don't have anything changing, so we're not going to need any mathematical blocks or the time block in here. We just need to make sure we put the correct coordinates. So in this final segment, the x-coordinate of the center of the pentagon is 60, and the y-coordinate is 40. So that should put it in the correct position. Perfect. You can see the pentagon is in the correct position. Now we just need to worry about the line. So the starting position of the line, let's duplicate and add the line. The starting position of the line does not change. So we're going to take this out as well. Let's determine what this starting position is. It has x-coordinate 60. So let's put that value here. And it has y-coordinate 50. Perfect. So now we actually see that the starting position of the line is correct. We just need to adjust it so that this end point is changing as time goes along. Well, once again, we're going to have to think about the relation between this change and time. So the y-coordinate of the point of the endpoint is not changing, right? It's not moving up or down. So we're going to keep this as 90. We're not going to worry about that. It's just moving to the right. At time equals 80, the x-coordinate equals 40. At time equals 90, the x-coordinate equals 50. Can you see what's happening here? Can you spot the pattern? At time equals 100, the x-coordinate is 60. So actually, the difference between time and the x-coordinate each time is 40. 100 minus 60 gives us 40. 90 minus 50 gives us 40. 80 minus 40 gives us 40. So we're going to do something very similar to this, but we're going to change this to a difference of 40 instead of 20. Let's make sure our pentagon shows and just check from the beginning that everything runs smoothly and the shape moves exactly as we wanted it to. And we can see that it has. Now notice that even though it's running correctly, I didn't get this indicator saying that the answer was correct. What I need to do is run and have it run from the start, go to the very end, and then it shows me this correct banner to tell me that the answer we have just written is correct.